Hello everyone, and welcome to this community of practice. Many of you will maybe be aware that there's usually a different chair here. So normally you have Joyce Dalgleish, who's doing the chairing for these sessions. She unfortunately couldn't make it today. She's on leave and she's asked me to cover instead. So my name's Shona Nicholl and I work in the data division in Scottish Government, the same as Joyce as well. And it is lovely to see everyone here today. So maybe just a little bit of background to the public sector data community. We're basically here to showcase, maybe highlight that innovative use of data and technology across the public sector. We're really here to inspire people and get you thinking about, ideas about what's possible in that public sector context and understand. And I guess we're really aware of the challenges that the public sector have and the systems that we operate within as well. So that's the sort of goal and aims of this community. The community has over 1,700 members, which is a massive number from Scotland and beyond, and I think will be continuing to grow. The online space that we're using today for these sessions is hosted by the Data Lab, and it is a place where we can share ideas, seek people to collaborate with us, and highlight opportunities and sign up for events like these as well. If you're not already a member, then please do join the Data Lab community where this public sector group is actually hosted. And members will receive updates on all of the different great events that are run through these communities, and opportunities as well through a weekly newsletter that the Data Lab publish. I know that over the next month, the Data Lab have got some amazing things lined up. I think it's the Open Data month is coming up in April, so please do keep an eye out on your inbox and sign up for things that you're interested in as well. But just a quick bit of housekeeping before we get started. The event is being recorded, so you won't have access to your cameras or microphones are going to be switched off. All of these, the recording will be made available through the Data Lab's YouTube channel after this session as well. But please do, although you don't have the ability to turn on your cameras or microphones, please do add in any questions that you might have as we hear the presentation. Put that in the chat. I'll be picking them up as the speaker goes through their presentation as well. And we'll try to take as many questions as we can during the time that we have, and we can always follow up afterwards too. As I said before, all of this material, the recording, the slides will be shared on that public sector community. So again, if you're not a member, please do join. And I think Stephen might be sharing how to do that in the chat as well. So that's grand. But anyway, on to today's session. We are looking at a session from Neil Sinclair from NHS NSS. And he's going to be talking about building insight at scale, supporting smarter evidence-led health and social care services. So I am going to stop sharing and I'm going to hand over to Neil. And I'll let Neil introduce himself and maybe take it away. So Neil, I will let you get started. Thank you.
Excellent. Thanks very much, Shona. Hi, everyone, and thanks for joining me today for this session. As Shona said, I'm Neil Sinclair, the Head of Data Services at NHS National Services Scotland. And over the next 20 minutes or so, I'm going to give you an accessible overview of Seer, which is Scotland's National Health and Social Care data and analytics platform. My aim today is to explain why Seer exists, what it does and how it's built, and most importantly, how it's being used right now to improve services and outcomes across Scotland. Sorry, I've lost my mouth. So let's start with what we're going to cover. We'll look at the strategic context behind Seer, what the platform actually is, its architecture, some key timelines from the last couple of years, and data pipeline modernisation work. I'll then walk through a set of real use cases to show how Seer is being applied in practice. Across the session, I want to highlight both the technical backbone and the real-world impact, because Seer is ultimately about enabling better decisions and better services. So before we get into the technology, it's important to anchor Seer in the national direction of travel. Scotland's data strategy for health and social care sets out three ambitions. Empower people by giving them access to and control over their health and social care data where appropriate to do so. empower professionals by giving staff the ability, confidence and tools to use data safely and effectively, and support service innovation by making data accessible in secure, trustworthy ways. These ambitions cut across the public service reform agenda and the health and social care renewal framework, and Seer is a major part of delivering on these ambitions, creating the enabling conditions for safe, high quality, scalable data access. So let's have a look at what Seer actually is. Seer is the national data analytics platform for NHS Scotland, helping healthcare staff access and analyse data to support decision making. You may have heard of the National Digital Platform, and Seer provides the data and analytical capabilities of that wider NDP, or National Digital Platform. The platform is a key part of Scotland's health and social care strategy and is recognised for its capability to deliver greater insights into the data held across the health and social care sector, and to support the three ambitions of the data strategy of empowering people and professionals and supporting service innovation. So let's unpack that a little further. Seer is the collective brand name for a collection of different capabilities, technologies and tools for data integration, management and presentation. It brings together a range of technologies to provide the core capabilities of data ingestion, data storage, data virtualization, analytics and reporting, AI and machine learning, and self-service data preparation. It hosts over 100 different data products, which can be single data sets or combinations of data sets. It also supports more than 500,000 reports and approximately 3,000 dashboards, indicating the extensive reporting and analytical activities conducted on the platform. It underpins data access and insight for over 20,000 users across NHS boards, Scottish Government, local authorities and academia. And the wide user base highlights the platform's importance and versatility. And all of this is supported by a core team of data professionals delivering, maintaining and continuously improving the platform and the data and analytical products that live within it. So let's have a look at the Seer architecture, starting with a high-level view. This is our long-term reference architecture, the capability view that guides how we design and deliver Seer. It covers the full data lifecycle, ingestion, lakehouse layers, warehouse, virtual integration, consumption, and governance. This gives us a modular, scalable, and future-proof reference architecture that guides how we design, build, and operate Seer longer term. Technologies may change, but the capabilities always stay constant. This provides stability and direction as the platform evolves. So how have we provisioned the capabilities outlined in this reference architecture? In our platform today, these are the technologies we deploy from ingestion through preparation and management to insight. I'm just going to talk you through this diagram. So starting on the left, you can see that we have many types of data source listed. Seer can essentially handle any type of data source, and this is what we're trying to show here. In line with the principles of the reference architecture, if we find we don't have the correct tools for a particular type of data source, we would adapt the architecture to enable this capability. Within the data ingestion box, which is the next box along, there's a number of technologies that we have implemented. GlobalScape is our file transfer tool of choice, managing the delivery of files from data suppliers to the Seer platform. And we've automated the routing of files from GlobalScape into the Seer landing zones. S5, just below GlobalScape, is an in-house built metadata-driven file ingestion and validation engine. In our old pipeline tooling, we used to have to write the ingestion processes and code every data validation rule. By implementing S5, when we have a new file type to process, we simply have to create some metadata about the file and the validation rules, and the engine will process the files automatically as they arrive. DLT is a tool we're using to connect to and ingest data from APIs and database sources. As we move to the right, we come to our data lakehouse. The first part of our data lakehouse is our data lake, which has been implemented in AWS S3 buckets, directly inside our AWS tenancy, and also inside our Snowflake tenancy. Our data warehouse has been implemented in Snowflake, which is a cloud-native database designed for data warehousing and analytical use cases. In our curation layer, we have our CJC engine, which is Corporate Job Control Engine, which again is an in-house designed metadata-driven engine, which allows us to standardize our data pipelines to use common code sets and templates and access the relevant metadata for a given pipeline. Also in our curation layer, we have a staging area set up in Snowflake, where we can land data for onward processing into the data warehouse itself. We then have our batch processing engine, which has been implemented using dbt, and this is where we do all of our transformation and modeling of data before loading it into the data warehouse. In the consumption layer, we have the data warehouse, which is implemented using Snowflake for our physical data warehouse, and Denodo to present the data for users to consume. The final part of the lakehouse that I'd like to point out is the virtual data integration at the bottom of the diagram, which is implemented using Denodo. This allows us to virtually integrate data rather than the physical integration that takes place through the dbt processing engine. Over on the right, we have our insight activation layer with a number of analytics and AI tools deployed for users to consume, analyze, and gain insights from the data. The final part of the architecture at the bottom of the diagram are foundational technologies that underpin the rest of the capabilities. We have Apache Airflow, which we use to orchestrate our data pipelines. We have some continuous integration and deployment tooling using Git and DevOps that allows us to automate code compiles, peer reviews, unit tests, and to automate deployment of code into the different environments we have within Seer. And we also have a number of tools which we use to manage the platform build, patching, and to monitor performance and costs. Next, I'd like to look at how we got here by highlighting some key milestones from the last couple of years. So Seer has been evolving at pace and builds on decades-long heritage of data and analytics platform. The latest version of Seer went live in November 2023, giving us a modern cloud-enabled platform, and we've been iterating on it to add more applications and data ever since. In 2024, alongside migrating Tableau and Denodo into our new cloud-hosted Seer platform, a key highlight and milestone was the replication of data from our already existing data warehouse into the new Snowflake data warehouse, and the creation of a validation framework to ensure that the data was accurate on replication, i.e. it was matching exactly our existing data in our existing warehouse. The final milestone in 2024 was the introduction of a new standard to ensure that we enable direct access to all new datasets in Seer, not just to reports and analytical outputs that are built on top of these datasets. They are, of course, only accessible if a user has been authorized to access them. So moving into 2025, due to the now cloud-based architecture and capabilities we introduced, we were able to introduce some new services. The Bring Your Own Code service, or BYOC, enables code managed by a business area or expert analyst to be integrated into data pipelines built by Seer engineers. And the Shiny App Deployment service is similar to BYOC in that it supports deployment of business managed code, but in this case, through the deployment of already curated Shiny apps. A key milestone for us last year was the design of our new data pipeline architecture, enabling us to start the migration of pipelines from our old tooling into this new architecture. So I'd like to look at a bit more detail at that data pipeline architecture and walk through some example pipeline workflows. So the new data pipeline architecture gives us modern, efficient pipelines with reduced licensing and platform overheads, as many of the new technologies we have implemented are open source, so the costs are based on compute and storage costs. It gives us faster load times. We've noticed significant improvement in load times using the new pipeline architecture, which reduces time to insight for users. It gives us simpler and more maintainable patterns. With the introduction of metadata-driven ingestion validation and the ability to template code in dbt, DLT, and Airflow, data pipelines are simplified and easier to maintain. It gives us better lineage and observability through automated documentation and lineage being available directly from the new tooling. And it gives us continuing integration and deployment enablement, automating peer reviews, unit testing, code validation, and deployments. This architecture means teams can deliver pipelines faster, more reliably, and with greater consistency. So let's have a look at some data pipeline pathways. This diagram shows how data is processed into Seer, where the data source is a structured file. GlobalScape is used by suppliers of data files to submit data, and these files are auto-routed from GlobalScape into our data lake. From there, our S5 engine will ingest the file and validate its structure and data according to the metadata and rules that we created for the file. If a file is invalid, we'll notify the agreed contact with details of the validation errors. And if the data is valid, we take the data into our curation layer and transform and load the data using dbt into our consumption layer. The data is then presented to the insight activation layer and the various analytics and AI tooling that exist. And it can also be presented for consumption by tools outside of Seer. The next pathway is where the data source is a database system or an API. In this case, DLT is used to connect to the data source and ingest the data into our data lake. Within DLT, we can set specific parameters to ensure we are only taking the data that is required for a specific pipeline run. So we may only take the data that has been updated since the last time we accessed data in the source system, for example. The data is then pushed into our curation layer, where we use dbt to transform and load the data into our data warehouse in our consumption layer. And the data is then presented to the insight activation in the same way as we did with the file data source. The final pathway I'd like to look at is how data is processed into Seer, where we use virtual data integration rather than physical data integration. In this case, if the data is file-based, we would go through the same process as before to get the data into the data lake via GlobalScape. If the data is database or API-based, we can connect directly to the source from Denodo data virtualization platform. And within Denodo, transformation logic is built to transform and model the data before it is presented via the consumption layer, where it is then presented to the insight activation layer in the same way as the other data sources. So, of course, looking at architecture of Seer can feel a bit theoretical, and it's always important to make these things tangible. So I'll give you a quick overview of a couple of examples to help illustrate how we're using the Seer platform. So creating insights from data was initiated to bring together a collaboration to drive improvements in data enabled by the Seer platform. Working with Scottish Government, Public Health Scotland and CFSD, a key focus area is around improvements in real-time management information to support decision makers across the system with a whole system picture. Enabled by Seer, we are able to bring together our data and expertise to create a near-time data service, delivering key management information in one place, accessible to decision makers across health and social care. That capability continues to enable us to respond rapidly to new demands, drawn on data from across the system to provide a shared picture, for example, on progress towards improvements in operational performance. It shows how modern technology can enable deep collaboration between organisations, leverage the data already available to us to automate and simplify data flows, and respond rapidly to new demands. The second case study I'd like to outline is Account for Blood. Now, we already have a dataset called Account for Blood that links patient transfusion data with acute clinical data to support audit, analysis, and benchmarking of appropriate use of blood components. The Infected Blood Inquiry identified the need for better information on patient treatments and outcomes, and the Account for Blood 2 data platform supports 3 core recommendations from the Infected Blood Inquiry. The use of medicinal products to minimise the need for transfusion, timely and accurate haemovigilance, and standardisation and benchmarking transfusion practice to support patient blood management. To achieve this, we will link a number of different datasets to transfusion data to enable this deep analysis of blood use and to ensure the standardisation and safe use of blood products across Scotland. So to wrap up, I'd like to highlight how Seer is providing the foundation for a data-enabled health and social care system. And there's 3 things I'd like to highlight. It uses modern technology infrastructure, a trustworthy, secure, scalable national platform for shared data services. It provisions high-quality national data sets, built once, used many times, supporting safer, more effective, more innovative care. And it enables innovation and collaboration, providing a platform where a skilled data workforce are empowered to use and interpret data confidently. So thank you very much for listening. If you'd like to follow up directly with me afterwards, then my email address is there, and please do feel free to reach out. And Shona, I think I'm passing back to you, and I'm happy to take any questions.
Oh, indeed. Thanks very much, Neil. That was really fascinating. And I do have a couple of questions. Before I ask them, I'm going to ask people if they've got any questions, please do put them in the chat. And I'll put them to Neil. But I guess I've got two. And one is kind of around the data quality aspect of all of this. So you did mention that you had, I think, the curation layer that was part of the data warehouse. And I just wondered what type, I mean, it might be different for every data set that you're getting in, but is there a standard assessment that you're doing on data quality as it comes into your warehouse?
Yeah, data quality is always an interesting area because there's times where you would want to let data through and carry out your data quality processes once the data is already processed into the data warehouse.
Yeah.
But where we carry out data quality on the data coming in is really to stop any bad data getting into the system. So anything that's going to compromise the quality of the analytics outputs. So we'd be looking at mandatory fields that are absolutely essential. So we'd be doing data quality on those types of fields. And we would only reject the data and send it back to the source system. I think one of the challenges with data quality is sometimes the system of record is where these data quality issues really need to be dealt with. So we wouldn't necessarily want to change the data on the way into the warehouse.
Absolutely.
We would rather reject the data and not process it at all.
Yeah.
Or the second thing we do is we raise warnings against the data and report it back to the system of record so that the next time we process the data is being corrected.
Yeah.
So we wouldn't have any standard data quality that we carry out across every data set, but we define it data set by data set.
The data set, yeah.
And as I say, we create that as metadata so that we can just automatically generate those data quality checks.
Yeah, I mean, that's super fascinating, and just interesting because it's always one of those kind of things that you're getting lots of data from lots of different sources, right? And some of them are going to have good data quality in place already, and others maybe are not. And it's just how you would deal with that. I did have one other question, and then I'll come on to some of the other questions in the chat. And I guess this is maybe just because I'm interested, this one, the virtualization. I thought that was fascinating. And that being able to bring APIs or other databases in through Denodo. But I guess so your current database is sitting in AWS. And I'm wondering if, say, for example, in Scottish Government, we had an analytical platform that was also in AWS. Is it like if you're both sitting, although you're in different tenancies within AWS, do you have to do virtualization? Like, is that the route that you would, or is there something because you're all in the same, I guess, cloud provider? I just wondered if there was something about joining up some of these big, analytical platforms that we're all generating right now or developing right now, and how that might work.
Yeah, I think it depends on the platform. So the use case for virtualization isn't necessarily to enable that. So where we use virtualization is to try and it's good for rapidly prototyping. So if we can just connect directly to the data and model something virtually, that's a much quicker process
that makes
than defining physical transformation processes and load processes. So it sometimes gives you that quicker insight into what the data is like, how you might want to model it in the future, allows you to prototype, and then you might look to physicalize something. On the question about how we can better share data, I think it depends on the technology, and if organizations are using similar technologies, it certainly makes it easier. Snowflake is a good example here, where we've started to use Snowflake as our data warehouse. And one of the projects we're working on at the moment is the Connect Me project, where we're trying to bring in data from home monitoring, so from a company called InHealth, who run home monitoring services, and they happen to use Snowflake as well. So actually, because they're using the same technology as us, they've been able to share the data directly with us via Snowflake. So that
Yeah.
data integration has become much simpler for us
Yeah.
through the use of the same technology.
Yeah, fascinating. That's really good to understand how you're using that virtualization process as well. Thanks very much, Neil. So we've got questions in the chat now. So the first one is from Malcolm. A couple of questions from him. One, is Seer an acronym? And two, how does this tie in with data sets from our Future Health and Biobank, or are they totally separate?
So Seer is, I normally say this when I present this, Seer is not an acronym. So it doesn't stand for anything.
Yeah.
As I said, it's kind of a brand name for a collection of
Yeah.
different capabilities and tools that we have, and we branded them under the Seer platform.
Yeah.
The reason we came up with the name Seer for the platform is, of course, a seer is somebody that can see into the future, predict what's going to happen, and we
Yeah.
are keen that we maximize the use of our data in those more advanced ways. If we can build up the data sets and use our insight activation layer to really
Yeah.
predict what's going to happen, we can start to affect the outcomes in the positive ways that we want to.
That's grand. And the second question was just about how does this tie in with data sets from, and I don't know what these are, but I'm thinking they're programs, our Future Health and Biobank, or
Yeah,
are they separate?
I'm not sure what they are, so they're
Okay,
obviously not part of Seer.
okay.
But
That's
so
probably
I'm afraid I can't answer that question, but I'd be happy to discuss it afterwards
Yeah,
if you
yeah,
want
no,
to get
that's
that.
grand. And Malcolm, it sounds like it's not, but if you wanted to give us a bit more detail in the chat, you could, and we can have another run at it or afterwards as well. We've got maybe two questions that are kind of related here about other types of data. So Aileen's asking about local government data. Has any local government data been added? And then David's asking about, are you only ingesting clinical data, or do you get sources from primary care or social care? So let's just say this is a general question about the different types of data that you get coming in.
Yes, okay. So we do have some social care data in the system. We've worked with Public Health Scotland to bring in some social care, but that would be the only local government data that we currently have within the Seer platform. In terms of the different types of data from health, it certainly isn't just clinical data. For example, we host all of the finance data for Scotland within the Seer platform. All of the procurement data for Scotland is in the Seer platform. We have blood data, I highlighted. We don't yet have primary care data, but we have started to look at that, and that's certainly on our roadmap for the coming year. So it's a broad range of data across health and care, we would say, and certainly not just clinical. We do have those other support and administrative type data sets, such as finance and procurement.
That's grand. Thanks very much. Hopefully, Aileen and David, that was helpful. We've got another question from, in fact, maybe, yeah, we'll go to, yeah, they're getting some thumbs up there. That's grand. So Chantel has asked the question about the primary factors that influence the choices for architecture. And she's just wondering, I guess, what the trade-offs were between security, ease of implementation and integration, and costs and that kind of thing. Is there anything you could share about that, Neil?
So is this in relation to the technologies we've implemented within that reference
Yeah,
architect?
yeah.
So I think we had some core principles. We were keen to look at open source wherever possible to sort of reduce costs, and I think to be part of that open source community as well has benefits outside of license costs and things. I think we were wanting to also be adaptable. So whatever technologies we were choosing, we were trying to avoid kind of strong long-term vendor tie-ins. So where we've implemented technologies such as Snowflake, that is essentially SQL-based. So if we decide in the future that actually there is a better data warehousing tool for our needs, we should be able to lift and shift because it is a SQL database, more or less, at the end of the day. With some of the other two technologies we've chosen, such as DLT and DBT, they're essentially Python and SQL based. So again, we're not really tied in to any particular vendor. And indeed, if we were to move anywhere else, even outside of AWS, all of that, those artifacts we've created using those tools, we would still be able to run them on another platform. So I think we had some core principles we used when we were selecting our technologies. And of course, we went through at the start of the process when we made the decision to go AWS and Snowflake. we went through a full procurement process of assessing the other options out there, so the other cloud platforms that were available and the other database applications that were available to us.
Yeah, I mean, I think in some ways, even just understanding that process that you went through, like you talked about favouring open source and then, but still having to go through a procurement, and sometimes that can be difficult, right? To be able to say we've made some decisions already about things as you go into that procurement as well. So, so Chantal, I don't know if that helped, if there was anything else that you wanted to ask about, please do put it in the chat as well if you had any follow-up questions to that. And I guess I've got maybe just one other question, and that'll give us a chance to see if anybody else has got any other questions. And this was to do with the users. So well, there's two questions in this, I guess. Firstly, I'm a geospatial, my background is geospatial, and I'd be interested to know if geospatial data and the use of tools that, geospatial tools is something that's being used. But you also mentioned lots of users coming from all across the Scottish public sector, actually, and just interested in how that works from a security angle. I mean, maybe if there's something you can share with us on that one as well.
Yeah, so obviously people only get access to the data if they've requested that access and it's been authorised by the relevant approver for their local organisation, or if it's a national data set, it might be a national organisation that approves that access. Once they've got access, we've got I didn't really mention it in the presentation, but it might be worth adding in. We've got what we call our CSI security model. That's our corporate security interface model. So on top of every data set, we build a security model that ensures that when people log in, they only see the data that they have been authorised to see. So if somebody logs in from a particular health board, then we will have a security policy in place, which means that they would query the data. They're querying all the data, but the data would only be returned for their health board. Now, again, when we design a data set, we might vary that. That might be based on patients who live in their health board or patients who are treated in the health board, but we would define that up front and decide what are the parameters around what people are allowed to see. So that's the first level. We can apply that at any particular level. We could apply that at a local authority level, a national level, a health board level, a health and social care partnership level. We could go all the way down to a practice or indeed a clinician. So if there's a clinician who was coming in and looking at a national data set, but they were only allowed to see data for people they had treated, again, we could apply that security model so that the data would only return for them. The second level of security we apply is confidentiality masking, which is where, depending on whether somebody has been given confidential access or non-confidential access, then they wouldn't be able to see confidential data items such as patient details, for example. They would be able to know that those data items exist. They can include them in the reports, but when they're returned in the reports, all of those fields would be blanked out because of the security policy that we put on to say that a person isn't allowed to see those confidential data items. So yeah, we've got quite a mature security model that we can apply to any of our data sets. And actually what it does is enable access to anyone.
That's
albeit
great.
apply the correct security model.
I mean, again, I find that absolutely fascinating and really something, something really interesting and things we think about a lot in Scottish Government as well. So really, really useful to know as well. So I guess anybody got any other questions for Neil? And if I'm not seeing anything in the chat, then maybe Neil, what I would just like to say is thank you so much. That was very interesting. And I think from my point of view, just understanding the Seer system, the sort of architecture there, the way that people can interact with it, the types of data that you've got on there as well, has been really, really interesting. I've heard about Seer. I did not know everything that it did or could do. So and I think it's I think there's some interesting things here about, you talk about this as an analytical tool, but actually some of the stuff that you mentioned is in that near time, almost operational use of data as well. So we're seeing a very broad platform that maybe caters not just for the analytical and research, but maybe also starting to move into that operational access to data as well, which I think is really fascinating. So yeah, Thank you so much, everyone. And thanks everyone for coming along. Oh, in fact, because I'm such a bad chair, I have to remember I do have some more slides to share at the end. So Neil, I'm going to share my slides again. Sorry, my normal community of practice that I run, we don't do slides at the very end, but Joyce does have some slides for everyone. So you're just going to have to bear with me for 2 seconds while I get to the end. Yep, so the things I was going to mention, I mentioned this already, but we are moving into the open data theme when we move into April, and we have an event on the 23rd of April for this particular community of practice. The next event is We Build Together. This is Public Sector Open Data for Scotland. It's actually some people on my team who are going to be talking about open data. It's going to be very fascinating, so please do sign up for that as well. And then just finally, I wanted to mention a couple of things that, particularly if you're in the public sector, you might be interested in. So again, Joyce in the team runs a data science and innovation accelerator program. It has just gone live. It is where people can get a little bit of upskilling along with some help from mentors and others to maybe work on a particular data science or innovation project. So if you want to find out a little bit more about that, please do take a look at the links that I've just posted in the chat. We're looking for both people who want to do projects, but we're also looking for mentors for people that can support people going through this program as well. And then finally, another thing has just gone live is some guidance that the team in Scottish Government, along with the Scottish Digital Academy, have published, which is just some training packages around data and foundations for data. And also we've got a little training package that's based on the data maturity programme that we run in Scottish Government as well. So please do take a look at all of these things. If you'd like to get involved, please do as well. And I now have come to the end of my slides, and I just want to say again a big thank you to Neil for coming along today. That was super fascinating, and thanks to everyone who joined us as well. So thanks very much, everyone. Thank you. See you later.
Thanks, man.
Thanks very much.